Hello guys, in this video we are doing reduction formula. So we want to know what is the purpose of reduction formula. Reduction formula is used to reduce bigger angles into smaller angles. Usually those smaller angles are acute angles. So we're gonna start with our quadrant on this plane. So we have 4 quadrants, 1, 2, 3, 4. So this one is represented by A, S, T, C. This means O, then sine, tan, and cos. If we say O, mean all trig ratios. We have 3 trig ratios that we're going to deal with. We have cos, sine, and tan. So if we say O, it means all of them they are positive. Then here we have sine. It means only sine is positive. This sine. The rest is negative. Then tan is on the only one which is positive, then the rest is negative. Here cos is positive, then the rest is negative. So we want to start with reduction formula on negative angles. So we need to label our quadrants. Well, we have marked our quadrants. Now I want to see what is here, what is there, and there. So at this point we have 0 degrees. Then here we have 90 degrees. This side we have 180 degrees. Then this is 270 degrees. Then this is also can be 0 or 360 degrees. So when you are measuring positive angles, for positive angles you go anti-clockwise. So we start at this one. This is our starting point. So if we want to measure positive 90 degrees, we start here, then we come. And that's where we have our 90 degrees. If we want to measure 180, we come here, then we have our positive 180 up until 360. Then from there, now we want to see the angle which is in this quadrant is theta. That's the angle which is there, because it's an acute angle, which is between 0 degrees and 90 degrees. Now we want to see the angle which is in this quadrant. So we move, then we have 180 degrees. But we want to stay in this quadrant, so we need to go back a little bit. We need to subtract theta. So this quadrant will be 180 degrees minus theta. Here we have a 180 degrees, but we want to be in this quadrant. So meaning we need to keep on adding an acute angle, so which is 180 degrees plus theta. Here we look at 360. We say 360 degrees, but we want to stay in this quadrant. We need to subtract an acute angle theta. So this is 360 degrees minus theta. So these are the type of angles that we have in quadrant 1, 2, 3, 4. So reduction formula, usually it applies from quadrant 2, 3, and 2, 3, and 4. For the first one, we can't use theta for the reduction formula, but what we can do, here we have 360 degrees. But if we want to continue to be in this quadrant, it will be 360 degrees plus a theta. So we can use this one, this angle, if we want to apply reduction formula on the first quadrant. So now let's see how we can simplify our angles in all those 4 quadrants. But let me start with the second quadrant. Second quadrant. So in second quadrant we have sine. Our angle is 180 minus theta. We have cos 180 degrees minus theta. Then we have tan 180 degrees minus theta. So what we need to do here, we check whether sine is positive or negative in that quadrant. Then we say sine is positive, so this reduces to positive sine theta. Then here is for cos. Cos in the second quadrant is negative, so it reduces to negative cos theta. Then tan, it reduces to negative tan theta. So we are saying this is the first quadrant, second quadrant, third quadrant and fourth quadrant. Then for the third quadrant now, we just do the same thing. We'll be checking which trig ratio is positive, which is negative. So for third quadrant is we have sine 180 degrees plus theta, then cos 180 degrees plus theta, then tan 180 degrees plus theta. Then we check is sine positive or negative in the third quadrant. Sine is negative, so it reduces to negative sine theta. Cos is negative, it reduces to negative cos theta. Then tan is positive, so it reduces to tan theta. So this is how we apply reduction formula on positive angles. So I will give you an assignment for you. You do reduction formula for fourth quadrant and for the first quadrant. Don't forget that for the first quadrant you use this angle, not theta, because theta is already reduced. It's an acute angle. So we just have to reduce this one.